Alright, last two logarithmic equations to solve. 21, we got log base 7 of 5 plus the log base 7 of x minus 3 is equal to log base 7 of 2x plus 3. On the left-hand side, we need to condense this thing down so that we can get a log on each side, just a single log. So we condense it down with the product property. If we're adding two logs, this turns into the product of what we're taking the logs of. Log base 7 of 5 times x minus 3 is equal to the log base 7 of 2x plus 3. Okay, so now since we have just a log base 7 on both sides, then that means what we're taking the logs of has to be the same. So 5 times x minus 3 is equal to 2x plus 3. Distribute the 5 here. 5x minus 15 is equal to 2x plus 3. Now we got to subtract the 2 over. So when I subtract the 2x over, I get 3x. Add the 15 over, and I get 18. Divide x equals 6. Now always whenever you have a logarithmic equation, you have to make sure that that number makes sense, that it doesn't create a domain issue. So you just stick it back into each one of the quantities, each one of the logs, to make sure that you do not get the log of something that is 0 or less than 0. Okay, so if I plug it in here, 6 minus 3, that'll be fine. And here I'd have 2 times 6 is 12 plus 3. That would also be fine. So x equals 6 is not an extraneous answer. It's perfectly okay. Okay, let's look at the last one, probably the toughest one. Here I am taking the difference of two logs. I need to condense that down just like I did on number 21. But subtraction condenses down to the quotient, dividing what we're taking the two logs of. So this becomes the log of the quantity 15 minus 9x divided by x minus 4 is equal to the log of 8x plus 5. Now we have logs on both sides, so we can just get rid of those because if we have two equal logs, whatever we're taking the logs of must be the same. So we have the quotient 15 minus 9x over x minus 4 is equal to 8x plus 5. Alright, so here's the equation that we have to solve for x. It's a rational equation, so it's best to just get rid of this x minus 4 that's on the bottom by multiplying it over to the other side. It's dividing 15 minus 9x, so we're just going to multiply by x minus 4 to get rid of it. So on the left-hand side, I still have 15 minus 9x, but on the right side, I'm going to have to do some foiling. So foiling this out, I get 8x squared minus 32x plus 5x minus 20. Okay, and now it's a quadratic equation, so we need to get everything to one side. 0 is equal to 8x squared. I have a negative 32x plus 5x, that's negative 27x. And we're going to add the 9 to it. Add the 9 to it, we're going to have a negative 18x. And then finally I have the 15 I have to subtract over to the other side, so it's negative 35. So some people use the quadratic formula at this point because they didn't want to try to factor. It's best to do it by guessing and checking because the numbers are kind of large. So two things that multiply up to 8x squared. I'm going to go ahead and try a 4x and a 2x. And then two things that multiply up to negative 35. Don't worry about the sign right now. Let's just, how about 5 and 7? So let's say a 7 here and a 5 here. Don't know if that's going to work yet until we go ahead and do the inside and the outside terms, the middle terms. So here I have 10x, and here I have 28x. Is there anything I can do with that to get 18? The answer is certainly, as long as I'm subtracting the 28 has to be negative, so it's a negative 7, a plus 5. Okay, so let me erase all of this garbage down here. Now let's set each one of those things equal to 0. So on the first one, I'd subtract the 5 over, divide by 4. X is equal to negative 5/4. And then on the next one, add the 7, divide by 2. It's 7/2. So you'd think that both of these things were your answers, but if you were to try to stick these in, both of them don't work. So just for example, let's take this negative 5/4. If I stick it into the second log here, negative 5/4 minus 4 is a negative number, and I can't take the log of that, so it's extraneous. 7 divided by 2 is 3.5. Same one, it's the same quantity here. 3.5 minus 4 is negative 0.5, and I can't take the log of that, so that one's gone, which means after all that work, the actual answer is no solution. And finally, we're done.